Good day. My name is Engineer John Vincent Obiwa. I am an electrical engineer by profession. The topic of our discussion today is electrical house wiring and installations. The important thing to discuss under this very topic, one, safety precautions, electrical safety precautions, very, very important. As an artisan or electrician, before you carry out electrical installation or wiring on electrical design, you must know the rules and regulations, the safety precautions. Disconnect the power before servicing on electrical equipment. Very, very important. You can also treat all electrical devices, okay, as if it is live or energized. Never assume that the power is off. Also, avoid contact with energized power. It could be very dangerous. It can result to killing or injuring yourself. Use only tools that are non-conducting devices when you're handling electrical equipment. Never use metallic conduits, conducting materials on electrical equipment. It can be very, very hazardous. When it is necessary to handle equipment that is plugged in, be sure that your hands are dry, and when possible, wear non-conductive gloves, protective clothing, and shoes, and also insulating materials. Very, very important. Okay. Work only with one hand if it's possible, keeping the other hand aside to avoid completing the circuit, thereby causing hazard. Minimize the use of electrical equipment in cold rooms or condensed areas. If possible, you can hang the equipment on a wall or on a panel. Do not allow children under 12 years to handle wire cords, because once a wire cord is broken or cracked, it could cause injury or could cause shock to little children. So children below 12 years should be very careful in handling wire cords. Also, adults above 12 normally have contact with electrical shock when they are playing around towers or electrical equipment. So I advise adults not to climb on electrical towers or playing around substations. It could be very, very dangerous. Enclose all electrical contacts after working on them. Never allow loose wires to be scattered, whereby access could be touched to the cables. Don't be smart. Don't think that you are too new. If an individual comes in contact with electrical wire or an individual is electrocuted, don't touch the person. Don't touch the live wire. Rather, go to the source and disconnect the power so that you can save yourself in that scenario. Protect yourself when lightning during summer period. Where there's lightning, you can easily run to a shade, or while surfing or swimming, kindly get out of whatever thing you are doing and then run for protection. Now, let's look at voltage, current, and resistance. What is voltage? Voltage is simply the potential energy the electrical charge possesses, which causes current to flow. It takes voltage for current to flow. Now, current is the flow or movement of electrons around a circuit. Okay, now resistance. Resistance in circuit limits the flow of current. That's what the resistance does. Now, I want to use the water system as an analogy to these very functions of voltage, current, and resistance. Water system can be used as an analogy. Okay, for a simple circuit, voltage can be the pressure that causes the water to flow on the water system, while the flow of the water serves as a current. Now, At the tap, where you turn the bulb, that's the valve. That's where the resistance, the function of the resistance is. By the time you turn the valve, you are actually controlling the flow of the water. So the higher the resistance, now limits the flow of the current. Okay? Now, the lesser the resistance, more current flows. A simple illustration is a DC circuit whereby a battery and a bulb is connected to a battery through a conducting wire. Now, the conducting wire connects the battery, and electrons flow from the negative side of the battery, then passing through the bulb, whereby light is emitted. Now, the battery produces voltage, which makes the current to flow, causing the bulb to emit. The light bulb, okay, has resistance itself, which limits the flow of current. The amount of current through the light bulb determines the brightness of the bulb. Let's look at the basic tools an electrician or artisan should use to work in the field. Look at the tape. You can also consider the tape as a measuring instrument, whereby you need to measure the dimension of rooms, the height and the width of the room. You can also measure the length of cable with tape. So tape has several functions in electricians, handling tools. Now, the cutting plier. Plier is very, very important. Use plier to, cut the conductors. And also use plier to peel the insulators on the conductors. Now, the linesman plier, can also be used to bend cables. Maybe used to stripe also insulated cable jackets. Also look at the wire strip or cutter. Very, very important. The wire strip or cutter is used for removing the insulations for various types of wire gauge, such as stranded and also twin core cables. The flat tip screwdriver is also another tool electricians or artisans use in electrical installations. These tools help you to screw some, the knot on electrical panels. You find those screws on panel. How do you handle them? You use screwdrivers to screw them. Very, very important. Also have multi-purpose. The screwdrivers are in different sizes. We have the flat screwdriver, have the star screwdriver that serve various purposes. Also have a cutter plier. Cutter plier serves several purposes. You can use cutter plier to, remove pins and nails where necessary from the installations. Also, the hammer is another tool that is very, very important as electricians or artisans work. Use hammer to hit nails where necessary and carry out other, important. The next tools I want to talk about is the measuring instrument. Here you can see a multimeter instrument. This multimeter, in the sense that you can use it to measure voltage, current, and resistance. This instrument is called digital multimeter. There are different types of multimeters. The one here is digital multimeter. Also have the analog multimeter. The digital multimeter is a sensitive instrument used for measuring voltage, current, and resistance by displaying numbers, whereby you are seeing the value of the measurement you are taking. Reading it on the screen. You have a screen whereby it displays the value. That's digital multimeter. And then when you want to measure resistance, you can easily switch the pointer to the north. Switch the pointer to the north. The pointer is pointing at the north. And then you can, the black lead is on the common, which is ground. And the red lead is on the volt and ohms terminal or resistance terminal. Now, when you want to measure resistance, you can now use the two lead for your measurement. For instance, now, if I want to measure voltage, I will switch my pointer to the east direction. Now, to measure the voltage, I'll place the black lead on one terminal of the battery, the negative terminal, and the red on the positive terminal of the battery. And it gives me the value or the value of the voltage being measured. That's simply how you can use your digital multimeter. Now, the analog multimeter, it has a needle that deflects. That's the difference with a digital and analog. Analog has needle that deflects, thereby measuring the quantity. So it doesn't give you the exact value of the voltage you are measuring. But the best instrument is digital multimeter. Also have the voltage tester. Voltage tester are also important tools electricians or artisans apply at work. When you want to detect the presence of voltage, use voltage tester to be able to dictate if their voltage is present or not. So voltage tester help you a lot. It has an indicator, has a glowing tube that shows the presence of a voltage in equipment or appliances.